Hi everybody, welcome to our third video on trig substitution. In the first two videos, we handled substitutions when you had expressions of the form a squared minus x squared, and then we replaced the minus, turned it into a plus, made it a squared plus x squared. In this one, we're going to spin this around and look at what happens when we have x squared minus a squared. Notice there will be no fourth video for x squared plus a squared, because that's the same thing. All right. When you have x squared minus a squared, the substitution that we're going to use is a secant of theta. Okay? You'll notice we don't use the cosines in any of these, cosine, cotangent, cosecant. You really could, it's just you're going to end up getting negatives everywhere that, well, we didn't want to get. So, okay, we use sine, tangent, and secant. Let's do an example of this. So say we wanted to find an antiderivative for the square root of x squared minus 16 over x to the fourth dx. So, according to our table, since I have this nice form, x squared minus 16, 16 is 4 squared, I'm going to use the substitution x equals 4 secant of theta. Okay, I find my dx. It will be 4. Oh, man, you need to know the derivative of secant. Ha! All right, what's the derivative of secant? Well, it's secant tangent. So 4 secant tangent d theta. Cool. All right, now we got to put it back into our antiderivative. So let's see. I have a square root of x squared becomes 16 secant squared minus 16. Once again, you see why we're doing this substitution with the 4 there, which was the square root of 16. It gives you the same number when you square it. And then what's going to happen, I'm going to factor out a 16, and I'll get secant squared minus 1. What was that? Yes, let's keep that in the back of our minds. Let's see, on the bottom I have x to the fourth. Okay, I need 4 to the fourth. Well, let's see, that's the same thing as 16 squared is 256. Secant to the fourth. And, oh, I need a dx. Okay, dx is 4 secant of theta, tangent of theta, d theta. Okay, so again, we have this square root that we need to simplify. Fine. Again, we pull out the 16, and what's it going to equal? So we have square root of 16 times secant squared minus 1. And that's the trig identity we need to remember is equal to tangent squared. Secant squared minus 1 is tangent squared. Remember the other way. Tangent squared plus 1 is secant squared. So this simplifies to square root of 16 tangent squared. Hey, that's nice. Square root of that's going to be 4 tangent. Okay, so let's do our simplification. Another line, so square root of 16 tangent squared was 4 tangent of theta over 256 secant to the fourth theta times 4 secant of theta tangent of theta d theta. All right, let's see. We have some constants we can manipulate a little bit. 4 times 4 is 16. 16 over 256. Okay, that's 1 over 16. So 1 over 16. Now, what do I have left here? There's a tangent. There's a tangent. That's tangent squared. All right. Then I have a secant over a secant to the fourth. That'll be over a secant cubed. And then I still have d theta. All right, where do we go from here? So it looks like we're at a really nasty point. But if we rewrite everything in terms of sines and cosines, it's actually going to be pretty nice. So let's sneak over here to the left, and let's see here. We have a tangent squared over a secant cubed. And if I write tangent squared as sine squared over cosine squared, and I write secant cubed as 1 over cosine cubed, and I do this division, Well, what's left over? Let's see, you have to divide by, multiply by the reciprocal. I get sine squared cosine cubed over cosine squared. And now 2 of the cosine squareds cancel. I get sine squared theta cosine of theta. Okay, this seems at least a little nicer. Let's refresh. Okay, so we've reduced our integral down to this integral, and it may look a little complicated, but hey, look, I have a function sine and its derivative cosine. This means a straight u substitution. Forget trig, just substitution should work here. So I'm going to do the substitution. U equals sine of theta, du equals cosine of theta, d theta. If I do that substitution, I get a u squared du. Hey, that's pretty nice. So I get 1/16 integral u squared du. That's a really easy one to integrate, 1/3 u cubed. So I end up with 1/48 u cubed, of course, plus a constant. I feel really happy, but why are we not done? I started with x's. I ended up with u's. I don't want u's, I want x's. So I'm going to have to back substitute. All right, but that wasn't so bad. U is sine theta. So this is 1/48 sine cubed theta. So I'm done, right? No, I want x's. Didn't you hear me the first time, huh? Just kidding. Okay, what do I got to do? Well, it's the same thing we've been doing in other videos. I got to solve for my theta. Hey, x was 4 secant of theta. That shouldn't be so bad. So theta equals, divide by 4, take the arc secant of x over 4. Okay, so now I need the sine cubed of the arc secant of x over 4. Again, that sounds crazy, but it's not. We're just going to draw our right triangle again. So let's do it. Here's our right triangle. There's our theta, and theta equaled arc secant of x over 4. As before, we know if I take the secant of the arc secant of x over 4, I get x over 4. So how do you find the secant? Well, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So if the hypotenuse over the adjacent is x over 4, then I label the hypotenuse as x and the adjacent side with a 4. Use the Pythagorean theorem. I get that the third leg has length the square root of x squared minus 16. And so now, what is it I needed? Oh yes, I'm going to need the sine of the arc secant. Fine. The sine is the opposite over the hypotenuse. So root x squared minus 16 over x. So I end up with 1/48. Okay, I'm going to need the sine, and we're going to cube everything. But let me just put that on the outside. What do we say? Root x squared minus 16 over x. And then we're going to cube that, plus our constant of integration. Okay, so it looks a little bit hairy. There's a lot of steps, but ultimately, right, we got to take it one step at a time. We have to learn our list of trigonometric substitutions. Once we apply the substitution, always remembering to convert even our dx's to d thetas, we go through, we compute an antiderivative as well as we can. Hopefully we end up getting something in terms of theta. At that point, we're going to have to convert it back to x. Always take the substitution you started with, convert it so that it looks like theta equals, it'll be some arc trig function, right, of some x over something. Then go to your right triangle in order to compute, well, whatever trig function of your arc trig function that you need.